Not too far from Earth in cosmic terms, a mysterious world drifts quietly within the shadows of space. Only 4.2 light-years separate us from this intriguing neighbor, a tiny step in the vast expanse of the universe. That world is Proxima Centauri b, a planet that has captured both scientific curiosity and the imagination of dreamers. Unlike an ordinary dot of light lost among countless stars, this planet orbits the nearest star to our Sun, Proxima Centauri, and has become a subject of extraordinary fascination. Recently, with the help of the James Webb Space Telescope, JWST, humanity has been given its clearest glimpse yet of this alien world, an image so profound that astronomers describe it not merely as a picture but as a window into a place that might contain the raw materials for life. This discovery raises fundamental questions. How did we manage to capture this portrait across the stars? What secrets can it reveal about our position in the universe? And could it truly host oceans, an atmosphere, or even life itself? Imagine a small but enduring star glowing in deep red against the dark backdrop of space. This is Proxima Centauri, a red dwarf star much smaller than our own Sun, barely 1/10 its mass. Despite its modest size, it burns with an energy that will outlast the Sun by trillions of years. Orbiting close to this star is Proxima b, circling tightly in only 11.7 Earth days, a year shorter than a free trial subscription. Its orbit lies around 20 times closer to its star than Earth does to the Sun. Because of this closeness, it is almost certainly tidally locked, meaning one half of the planet is locked in perpetual daylight while the other half remains in endless night. Between these two extremes exists a thin twilight zone, a fragile boundary where conditions might allow for habitability, a precarious balance where life could cling to existence. What makes Proxima b even more compelling is its position inside the so-called Goldilocks zone, a region where conditions may allow liquid water to survive. Water, the essential ingredient for life as we know it, makes this orbit especially interesting. Since Proxima b receives nearly the same amount of energy from its star as Earth does from the Sun, the possibility of oceans, lakes, or even flowing rivers beneath alien skies excites scientists. Could the planet have an atmosphere to shield potential life from the dangers of space, or is it simply a desolate, barren rock scarred by the violent radiation of its star? These questions, though speculative, stem from our deeply human need to know whether we are alone in the cosmos. The planet was first discovered in 2016 using the radial velocity method, a technique that identifies planets by detecting the slight wobble in their stars caused by gravitational tugs. This wobble shifts the star's light in tiny ways, known as Doppler shifts, much like the changing sound of a siren moving past. The method confirmed that Proxima b is a rocky world about 1.2 times the mass of Earth, orbiting within its star's habitable zone. The announcement caused enormous excitement among astronomers, sparking dreams of studying a nearby exoplanet with unprecedented precision. This dream became more tangible with the launch of the James Webb Space Telescope in 2021. Positioned a million miles away from Earth at the L2 Lagrange point, Webb's 6.5-meter gold-plated mirror is finely tuned to detect infrared light, the very spectrum where red dwarfs and their planets shine brightest. Unlike Hubble, Webb can cut through cosmic dust and reveal faint planetary details. When it observed Proxima b, the telescope didn't merely record a blurred spot of light. Instead, it revealed variations in brightness, possible heat signatures, and even hints of an atmosphere. Using tools like a coronagraph, which blocks a star's glare to reveal orbiting planets, Webb offered humanity one of the most detailed views ever achieved of an exoplanet. Yet, much remains uncertain. Red dwarfs like Proxima Centauri are infamous for violent stellar flares, explosions of ultraviolet and X-ray radiation powerful enough to strip a planet's atmosphere in just millions of years. On Earth, our magnetic field and thick atmosphere protect us. But if Proxima b lacks such shields, its surface may be sterilized by relentless radiation. Even if it retains an atmosphere, it might be harsh, thick, and suffocating, resembling Venus more than Earth. Scientists caution that existing in a habitable zone does not automatically mean being habitable. Many other factors such as magnetic protection, geological activity, and atmospheric chemistry play crucial roles. If water exists on Proxima b, it could take many forms. Vast surface oceans under the star's dim red glow, frozen caps locked in eternal night, or hidden underground lakes insulated from extreme surface conditions. Some models suggest that if the planet has an atmosphere, it might help distribute heat across its surface, creating a livable twilight ring along the boundary between night and day. Such an environment could allow microbial life, or perhaps more complex ecosystems, to adapt to its unusual conditions. Proxima b is part of a larger stellar family. Its host star belongs to a gravitational system with the binary stars Alpha Centauri A and B, together forming a triple star system. This makes the region rich with possibilities, perhaps holding even more undiscovered planets. Beyond its scientific significance, Proxima b carries cultural weight. It is our closest potential neighbor in the galaxy, suggesting that habitable worlds may not be rare. It stands as both a scientific target and a symbol of our collective hope, reflecting the possibility that the universe is full of life. Some scientists even imagine it as our first interstellar destination. While no spacecraft today can carry humans to another star, projects like Breakthrough Starshot propose sending gram-sized robotic probes, pushed by powerful Earth-based lasers, at speeds up to 1/5 the speed of light. Such probes could reach Proxima Centauri in just over 20 years, a single human lifetime, and beam back the first close-up images of another planetary system. Meanwhile, massive new observatories on Earth, such as the Extremely Large Telescope, ELT, and the 30-meter telescope, TMT, will soon sharpen our ability to analyze Proxima b's surface and atmosphere, perhaps even revealing biosignatures, the chemical fingerprints of life. Despite these technological leaps, the cosmos gives up its secrets slowly. Every answer spawns new questions, and each discovery deepens the mystery. We now know Proxima b exists. We know it orbits within its star's habitable zone. We have preliminary clues about its surface and potential atmosphere. But is it truly habitable? Is it Earth-like, or more like Venus? Is it a beacon of possibility, or a warning about the fragility of life in harsh environments? The lack of certainty is not failure. It is the nature of exploration, requiring patience, humility, and persistence. Perhaps this is Proxima b's greatest gift, not definitive answers, but a reminder of the vast unknown and the thrill of discovery. It shows us that humanity's story in the cosmos is still being written. Whether Proxima b turns out to be alive or lifeless, its very presence inspires wonder and fuels our drive to search beyond Earth. The observable universe stretches an estimated 93 billion light-years across, yet this vast expanse represents only what light has had time to reach us since the Big Bang. Beyond lies the unobservable universe, perhaps infinite, forever hidden due to the finite speed of light. This division between what we can see and what exists profoundly shapes our understanding of reality. The light from galaxies observed today began its journey over 13 billion years ago, carrying with it the history of the early cosmos. One of the most remarkable breakthroughs in this exploration has been the discovery of exoplanets, worlds orbiting stars beyond our Sun. Since the 1990s, thousands have been found, ranging from massive hot Jupiters close to their stars, to icy rogue planets drifting freely in interstellar space. Among them, the most exciting are Earth-like worlds in habitable zones. Each discovery strengthens the possibility that life could exist elsewhere. Instruments like JWST analyze the faint starlight filtering through exoplanet atmospheres, detecting molecules such as water vapor, methane, and oxygen. While no proof of extraterrestrial life has been confirmed, the existence of billions of such planets across the galaxy suggests that Earth may not be unique. The universe, however, is more than planets and stars. Galaxies themselves form part of the cosmic web, a vast structure of filaments bound by dark matter and shaped over billions of years. Dark matter, though invisible, reveals itself through its gravitational pull, while dark energy, even more mysterious, drives the universe's accelerating expansion. Together, they make up about 95% of the cosmos, leaving only 5% for all the stars, planets, and living beings we know. Looking ahead, upcoming missions such as the Nancy Grace Roman Space Telescope and Europe's Euclid Observatory will map cosmic geometry, probe dark energy, and uncover more distant galaxies. At the same time, next-generation ground-based observatories will give us sharper views of alien worlds and cosmic structures. Ultimately, the universe is a paradox, staggeringly vast, yet intimately connected to us. Every atom in our bodies was born in the heart of ancient stars that exploded billions of years ago, scattering the building blocks of life across space. To explore the universe is, in many ways, to explore ourselves. Though the scale of the cosmos can make us feel small, it also reveals that we are part of something infinitely greater. As technology advances and curiosity endures, we continue pushing the limits of knowledge, driven by the same timeless question: what lies out there? Whatever the answer, it will reshape not just our science, but our very understanding of existence itself.